Hello. Walking is the physical movement of a body from one point to another over a period of time. Walking naturally requires motion, and the only thing that can interfere with motion is the presence of an obstacle. This definition of walking applies to all living creatures, except for two cases. The first is insects and some very small creatures. The second is Spider-Man. Those two are the only ones that seem completely unaffected by obstacles while moving. But let's put Spider-Man aside for now, and focus on insects, more specifically, ants. Ants are among the creatures that represent a true miracle of nature in almost every field, whether it's building, surviving, being constantly active, or working tirelessly. And what makes them even more impressive is their incredible ability to overcome any obstacle in their path, and even walk on top of anything they encounter. If you ever try to block an ant's path with your hand, you'll find it climbing right over your hand without hesitation, passing across it, and reaching the other side. And if it's feeling particularly sassy, it might even bite you on the way. As if to say, please don't ever try that again. But aside from your bitten hand, the real question is, how can an ant walk on literally anything it encounters? Even if it's upside down? Or in a direction that goes against gravity? Is it just because ants have a lot of legs? Or is there something more to it? Welcome to Deep Questions channel, but before we dive in, don't forget to hit subscribe and turn on notifications so you never miss our latest video. To understand how ants do this, we need to consider something extremely important. The dimensions of the world are completely different for us compared to small creatures, especially insects. Even the way natural phenomena occur differs greatly between us and them. What does that mean exactly? Let's imagine a piece of land that has a few small cracks in it. Now, if a person is standing in front of it and wants to cross, it's totally logical that he'll cross it easily. He might even step over the cracks without noticing them at all. Why? Because his feet are much larger than those cracks. But now let's replace that person with an ant trying to cross the same land. In this case, those tiny cracks, the ones the human didn't even notice, become catastrophic obstacles for the ant. To the ant, they're like giant pits and deep crevices in the earth, the kind you'd find in valleys or canyons. This is because the scale of the world for us is very different from the scale of the world for the ant. So, does that mean that the size difference between us and ants gives us an advantage? Actually, not always. In some cases, the small size of insects works in their favor. Take water, for example. Some types of insects can actually walk on the surface of water. This is because surface tension, and the attractive forces between water molecules, are extremely strong compared to the body weight of an insect. They're strong enough to hold the insect up and allow it to move across the surface. Humans, on the other hand, are far too heavy to do the same. And this idea can be applied to the way ants walk on walls, ceilings, and any surface they encounter. If we take a closer look at the structure of an ant's foot, we'll find that it contains tiny claws, kind of like the grappling hooks used by climbers to scale rocks and mountains. In addition to that, the ends of their legs also contain tiny pads or sensors. But why do ants need both claws and sensors in their feet? Wouldn't one of them be enough? Like, why not just claws, for example? Well, the reason ants have both tools is because they encounter two different types of surfaces. Rough surfaces and smooth ones. And depending on the type of surface, the ant activates the suitable mechanism to deal with it. Let's start with rough surfaces. Ants can only use their claws on rough surfaces, not smooth ones. But here's something important to understand. There's a big difference between a surface that looks smooth to us and a surface that is smooth to a creature the size of an ant. A surface that seems smooth to the human eye might actually be very rough from an ant's perspective. If you were to look at it under an electron microscope, you'd see it's full of ridges, lines, and tiny obstacles. These rough details allow ants to anchor their claws and move easily across the surface. Okay, but what happens in the second scenario, when the ant encounters a completely smooth surface? Like glass, for example? That's when the second tool in the ant's foot comes into play. The pads or sensors. If you're wondering what these pads are like, think of them as tiny suction cups, kind of like the plastic cups used in certain games or competitions where people climb walls using suction power. This is exactly how ants climb smooth surfaces like glass. They use their sticky pads to grip onto the glass, almost like a vacuum seal. Then, in a fraction of a second, they release the suction, take a step forward, and reattach the pads to the glass again, and repeat. This goes on until they've completely crossed the smooth surface. So in simple terms, ants use two different tools to walk and climb. Claws, when the surface is rough and full of gaps and edges, from the ant's scale. Sticky pads, when the surface is smooth, like glass. It's worth mentioning that some insect species have an extra option in addition to the two tools we mentioned. And that option is the ability to secrete a thin layer of oil or sticky substances from their feet. These secretions allow the insect to stick to ceilings with incredible strength. One of the most well-known insects that does this is the cockroach. This ability allows them to remain completely stable while moving across walls and ceilings. And here's a little message we'd like to direct specifically to the girls. If you ever see a cockroach standing upside down on the ceiling, there's no need to scream. It's not going to fall. Just stay calm, leave the room quietly. Then call the police or special forces, and they'll take care of it for you. Now, another important point. Walking upside down on ceilings is actually a very exhausting and difficult task for certain types of ants. Yes, ants can do it. But it's not their favorite thing to do. Not all ant species have the ability to walk upside down or against gravity. Most of the ants that can do it easily belong to species that live in trees, gardens, and fields. And those are particularly good climbers. And ants from those species don't just walk on ceilings. They can do it while carrying heavy objects many times their own body. Now that we've explained all of this, is the ability to stick to walls and ceilings something exclusive to insects? Actually, no. Many reptiles have this ability too. Several reptiles can climb walls and ceilings and stick to them effortlessly. And the most famous of them is the gecko. This creature has an extraordinary ability to stick to ceilings. It can stay completely still in the same spot for very long periods, sometimes even days. And it can carry loads tens of times heavier than its own body weight, while standing upside down, and never falls. All of this is thanks to the special pads and adhesive structures in its hands and feet, which allow it to grip the microscopic textures of any surface. Even though other reptiles can climb, the gecko outperforms most of them when it comes to sticking to vertical and inverted surfaces. Before we end the episode, let's ask a question. Can we somehow benefit from how insects and certain animals stick to walls, and apply that in our daily lives? The truth is, yes, we can. In fact, these natural mechanisms have already been applied in several fields. Take Mercedes-Benz, for example. They hired researchers from the Max Planck Institute to study how certain insects manage to stay firmly attached to moving surfaces without falling. Based on that, scientists placed an insect on a circular copper disc and began spinning it gradually. They expected the insect to fall. But surprisingly, it didn't. It stayed perfectly still, no matter how fast the disc spun. They increased the speed all the way up to 3,000 revolutions per minute. And the insect still didn't fall. That's when they began developing technologies based on this sticking ability, to help car tires grip the road better and prevent them from slipping, no matter how fast they spin or how sharp the turn is. And that's just one example. Other applications include ultra-strong glues, or systems that help robots walk and balance. Even more surprisingly, there are current proposals to use the same idea to create special gloves and shoes that would allow rescue workers and firefighters to climb walls and perform their tasks with ease. And although that may sound like something out of a comic book, it's actually a real possibility. History is full of examples where humans borrowed technology from the animal world. So don't be surprised if one day you hear about gloves and shoes that let you walk on walls. And for all we know, some teams might already be working on it right now. That's it for today. And don't forget, if you've ever had a random deep question hit you in the middle of the night, write it in the comments below. Most of our current videos actually come from viewer suggestions.